It's today's sections we have seen about unit 3 detection devices. Okay, is a detector is nothing but convert the radiations into the measurable quantity. There are two types of the detectors, thermal detectors. The next one is a quantum detectors. So thermal detectors is a variation of detectors parameters with the temperature due to the absorptions of radiations. Quantum detector is due to the interaction of photons with electrons. So these are the examples of thermal detectors. Then quantum detectors. Next one, first of all, we haven't seen about one by one what do you mean by photodetectors, what do you mean by thermal detector. First of all, we have seen about photodetectors. Is a photodetector is made up of semiconductors materials. Observe the incidence photons which produce the electrons. The electric field imposed on photodetectors and electric current is equal to photocurrent is produced in photodiode. This is the block diagram of optical receiver. Photodetectors are classified as a thermal or photon devices. The output of thermal detectors is usually the amount of energy absorbed per unit time by the detectors, and the absorption efficiency is same at the all wavelength. And this is the basic requirements of photodetectors. The next one is a thermal detectors. Thermal detectors is to gain an insight into the performance characteristics of thermal detectors. It's considered the behavior of the simple models. First of all, the incoming radiations is absorbed within the sensing elements of heat capacity H. This is connected to the heat sink at the constant temperature Ts via heat conducting link which has thermal conductance considered as a G. If the instantaneous rate of heat absorption is given by W, then during a small time interval delta T, the heat absorbed is W delta of T. If we let the temperature of elements be Ts plus delta T, then during the same time, the interval of the amount of heat lost through the thermal link is J of delta T is a del T. The difference between two represents the amount of heat available to rise the temperature of elements can be written as W del of T minus G of del of T del T equal to H del of delta T. Okay, this is the block diagram of thermal detectors. Okay, next one is a thermoelectric detector. It's a thermoelectric detector use the principles of thermocouple, whereby heating of one junctions between the two dissimilar metals related to the other cause a current to flow round the circuit which is proportional to the temperature difference between the junction. The thermoelectric detector's one junction is used to sense the temperature rise of the receiving elements while less the other maintained at the ambient temperature as shown in figure. A rather more sensitive detectors may be made by connecting the several thermocouples together in series. The device is then known as thermocouple. Efficient operations calls the materials with large electrical conductive and also small thermal conductive. These two equipments are usually incompatible and compromise has to be reached. Next one is next we have see about bolometer. This is the block diagram of bolometer. It's represented by bridge type. The bolometer is instant radiations heats fine wire or metallical strips causing a changes its electrical resistance. This may be detected in the several ways. For example, the elements may be inserted into one arm of Weinstein bridge or placed of the photoconductors. Care must be taken to ensure that any current flowing through the elements are sufficiently small not to rise the temperature by the significant amount. The main parameter of interest in assessing the performance is the temperature coefficient of resistance alpha, which is given by the alpha equal to 1 by beta dp by 1 by b dp by dt, where p is the resistivity of materials and t is the temperature. The resistivity of metals increased with increasing temperature, and hence there is a alpha will be positive quantity. Platinum and nickels are most commonly used. Pneumatic. This is the block diagram of pneumatic detector. This is the working function of pneumatic detector. The receiving elements of pneumatic detector. This is the block diagram. Okay. The receiving elements of pneumatic detector is placed inside an airtight chamber. Radiations falling on the elements causes the air temperature inside the chambers to rise, hence its air pressure to increases. This pressure increases may be detected in several ways. In one of the most sensitive detectors, the glass cells or a wall of the chambers has a hole in its converter by flexible membranes silvered on its outside surface. These act as a mirror whose focal length depends on the pressure within the chamber. A beam of light originating from a source passes through the grating, is then reflected from the flexible mirror to repass through the grating, and finally is directed onto the detector D. When no radiation is being observed within the chamber, the optic is arranged so that an image of the transmitting region of the grating is superimposed on the transmitting region, and there is then no output from D. However, if the mirror changes its curvature slightly, light will be transmitted through the grating of recorded by D. The output from the D is proportional to the amount of radiations observed within the chamber. This is the working function of pneumatic detector. By this, okay, thank you.